Hi everyone, thank you for coming along today. I really appreciate it. Today, as we've said, we're talking about AI in manufacturing, and specifically me trying to go for kind of the King and I type of title, talking about historians, the data collection and consolidation capability in manufacturing, as opposed to actual historians. So if you thought this was a history and AI session, I apologize. Hopefully it'll still be interesting anyway. So a little bit about me, if you haven't had a chance to chat with me or see any of my prior talks. I'm a techie by trade, but I really enjoy helping businesses adopt new emerging technologies that help them do things in better ways. I'm a regular presenter and keynoter across the world, and I organize conferences and things in my spare time. And Microsoft recognized my influence inside the technical communities around data platforms and artificial intelligence with the Microsoft Most Valued Professional Awards. You're very welcome to get in touch with me. I'm on Twitter, you can get me on LinkedIn, and of course you can send me emails after the event as well. So today we're talking a couple of topics. I'm going to overview artificial intelligence for you. No deep maths, no Greek letters, nothing too complicated, just a light overview about what AI is and what it isn't. We're then going to look at the kind of history of manufacturing and how much data comes out of it these days. We're going to look at the application of AI based on that data, and then we'll wrap up. So at a high level, what is AI? Cynically, AI is just whatever is really hard to do right now, computer-wise. Practically, that means that artificial intelligence is really about trying to do things that humans do very easily, but computers can often struggle. But it's becoming increasingly easy to buy artificial intelligence capabilities off the shelf and have them just work inside our systems. So as I said, AI is focused on the computational tasks that achieve what humans do quite easily. The core focus for us today is in the reasoning section. How does a human, somebody who understands the machinery, the process, look at what's going on and work out there's going to be an issue? They integrate lots of pieces of data that are coming at them and use that to make a prediction. That's the kind of capability that we're focusing on during this session. But also, AI performs other cognitive tasks, which include understanding content, whether that's text, voice, or images, or video, and doing things like working out if there are health risks inside on the shop floor. Is somebody walking around without a hard hat? Is somebody missing their gloves? AI gives us that sort of understanding of what's happening to be able to make informed decisions and act about our environment. And then interacting. How can we help people get their jobs done more quickly through voice commands, text commands, gestures? How can we help them get the job done using computers? So these are the key areas that AI plays in. So it's a big area. And And it's one that many companies are putting in a substantial amount of investment into at the moment. I saw a paper come out a couple of weeks ago that said even during COVID-19, reducing how much businesses are going to spend, European organizations are spending $10 billion this year on AI. So there is a substantial amount of investment going in to trying to use AI to augment existing staff and automate away tasks to help staff be more productive. Some of the different subsets of AI that you might see and that you might want to go and learn about: computer vision. So the health and safety risks on the shop floor is a great example of a computer vision AI challenge. Natural language processing would be taking engineers' field reports and things like that, and being able to identify common root causes and trends and relationships based on the handwritten notes. After, of course, using computer vision to try and decipher what those notes say when they're handwritten. Conversational interactions would help the field engineer write their experience in a more interactive way, or they could dictate their experience, and we could use speech processing to turn that speech into text. We could also make translations of what's being said and make that available. Knowledge mining is sifting through all the documents, for instance, your contracts and supplier agreements, procurement processes, quality control, validations, and building relationships between different things and helping you work out salient clauses, like identifying what all the intellectual property clauses are and looking for key differences. Induction is a big part of the reasoning task that we'll be looking at today. Induction is the process of going from a number of specific instances of something happening and being able to create a general rule. So we do this as humans. If we didn't have a knowledge of physics, day in, day out, we see the sun rise and fall. And because of the number of specific instances we see, we can come up with the rule that the sun will always rise and fall. And we might end up with the rule that the sun orbits the earth, which can be one of the risks or pitfalls of using pure induction, is we see a phenomena and we abstract from it. But that's the sort of area that we're going to be looking at today, and that's why some of those risks are worth thinking about, because you don't want to draw false conclusions. So we try and make sure that we put in rigorous controls to avoid problems down the line. This is not the first time that AI has been big. In particular, there was a huge demand in the 80s for expert systems, but we had some problems with expert systems. So the idea was that you have some wonderful subject matter experts. They know the ins and outs of your business, they control it. And the premise was, if we could just write down all the rules, all the things that they do and try and turn it into a deterministic system. So if this, then that, then we would be able to have computers program our manufacturing floor and be able to do things as the experts would. The problem with that is that whilst experts can be more flexible and build fairly future-proofed rules, you have to end up with this really quite deterministic system that translates really an expert's kind of more nuanced, fuzzy, it depends, and lots of the detail associated with its system. The other flip side is a more data-driven AI, and that's what we have at the that's what lots of investment is going into at the moment. The idea being that the information that gets captured from all your systems represents those systems. So if you've encountered the concept of digital twins, where you can make a digital equivalent of your machinery and say, this is where data gets emitted, and you can build virtual machine manufacturing spaces and see how they'll work without needing to invest in huge amounts of actual plant, then the data is the representation. This is beneficial in that it includes how things currently work or how things used to work. It's problematic in some circumstances because it represents how things used to work, and you might want to be able to adapt more quickly. So again, like one of the risks that we have with a data-driven approach is, for instance, we might not have data covering the breadth of scenarios that we need or expect. So a lot of like e-commerce algorithms and demand prediction algorithms right now are struggling because they were not built including, for instance, data on the last couple of economic depressions that we've suffered. So they were models that work well in good times, but have really struggled with COVID-19. So data systems are also not perfect, but they can be very useful for evolving a view as to what normal looks like and being able to help you check that normal is carrying on. And this makes that assumption that what's happened recently, or whatever time period you're kind of building up your data-driven model of, that the future is going to be pretty similar to that. So you end up needing to regularly update your model to account for any changes in your systems. We're focusing, as I said, a lot on this kind of data-driven system, and that uses techniques called machine learning, and a subset of that often called deep learning, where we take multiple passes through the data and optimize the prediction capability without an expert specifying how that model should work. And is it robots? So robots can very much be an area of AI. Because robots often need to sense their environment, usually through sound, image, and video, they're performing a cognitive task. Then, for things like being able to dynamically pick up different objects, as well as being able to understand that that is an unripe tomato and that's a ripe tomato and that's a person, they need to be able to have some sort of prior induction process happen that says the unripe tomato can be picked up with this sort of strength, the ripe tomato should be handled this way, and you definitely shouldn't try and pick up the person. So when our automation and our robotics are including that level of sophistication and has that capability of varying its actions, that's usually because there is artificial intelligence processes running inside the electronics. If it just does the same thing every time and somebody programmed it specifically to perform those tasks and it doesn't deviate from them, then that's usually not considered artificial intelligence. Okay. I'm going to give you a little bit of data science and AI. As I said earlier, though, no maths, I promise. So one of the key things that you can start doing with data that comes off of sensors, things like temperature gauges, RPMs, anything that gets measured really inside a piece of machinery, you get a continuous signal, or a signal that gets output at increments. And as we build up that view of that data, we can start working out what is normal for that machinery. It could be that it's normal for it to be turned off between like 10 p.m. and 6 a.m. And then it has a warm-up phase. Then the temperature should stay kind of plus or minus 2 degrees throughout the day, and then it'll have a cool down process. If the temperature is like at 5 degrees higher than it should be throughout the day, then that's an anomaly. But if the machine runs on for longer than it should do, that is also an anomaly because it is different to normal. So anomaly detection is the process that allows us to work out when something is unusual inside our data. And it's specific, one of the things that we can use most easily is time series anomaly detection, where a time series is a repeat observation of some numeric value. So that's one of the key tools in our arsenal for working out potential problems, is anomaly detection. Then we can do supervised learning. Supervised learning doesn't just look at one piece of information, it looks at a wide range of pieces of data and tries to understand why something is happening. So the most common situation here is something like predictive maintenance, where we're trying to understand what causes breakdowns so that we can put in some alerts and kind of watchguard solutions to preempt the problem. And with supervised learning, you have an outcome, and then your model, your set of rules gets built based on an algorithm that tries to distill lots of these independent rows of data into something that is a basic rule. I say basic, it can get quite complicated, but fundamentally it is a set of rules that say if this value times this value plus this value times that, if all of that's greater than like 50-50 odds, then we think there's going to be a breakdown. The great thing about typical supervised learning, kind of more classic techniques, is that these enable us to understand the drivers of the situation very easily. So you can use things like decision trees or regression algorithms, and they provide a way of saying, if this, then that, or give you a numerical estimate as to how something impacts your chance of a breakdown. So this is great for insight. It helps you understand the key drivers as to why something happens. Then with deep learning takes it further. As I said, the process can optimize itself. The aim here is less for explainability, more for high accuracy. And instead of a human saying, these are the things that matter to whether there's going to be a breakdown, and kind of gathering just those pieces of information, usually with a deep learning system, we'll take all the data, all the columns, and the machine will work out what's important, give those things a high weighting, and end up with an answer that is usually more accurate than a more traditional supervised learning technique. There are efforts into making it more explainable, but this is a solution that is better for high accuracy and rapid response rather than insight and a human going and acting on things. So that's a whistle-stop tour of AI and some key machine learning concepts. Now we're going to kind of go into the more manufacturing side. So fundamentally, to be able to do something, we need to know what's happening. And when we first started doing manufacturing, when we were doing things by hand, we had kind of 5 key inputs. We had our 5 senses. There's the smell for checking out whether something was burning, touch to be able to check out the grain, smell, I already said, taste. You know, we have 5 key input capabilities, and we can use these to work out whether things were going well or whether things were going not so well. We're highly optimized to process these 5 senses. It got complicated though when we started building up assembly lines. As we started putting machinery and people inside these processes, it was no longer sufficient. There was no longer just 5 senses worth of data coming through to be able to work out whether there were any problems. People started having to read numerous gauges, be able to put systems in place to get signals from individuals that something on their 5 senses was going wrong. So we've already seen a huge increase in data that was being generated, but of course they didn't have a way of storing or using that data, so it was usually a people-heavy aspect, people who would oversee the shop floor, and they would try and deal with things as it came up. And the only way they could learn about things that were likely to go wrong was to be there when things go wrong and learn from that. So they would perform induction. Now it's even more complicated because we have more and more automation and machinery and robotics inside our manufacturing processes. I was talking to somebody who was working in the manufacture of sheet metal, and they said their shop floor, their plant had gone from 500 sensors 15 years ago to more than 5,000 sensors per machine. Where previously they were able to kind of look at that data and process it and be able to kind of produce some reports. With more than 5,000 per machine, they couldn't cope with that breadth of data and be able to work out the meaningful insight in it, and even struggled with traditional database systems, which put limits on how many even like columns of data you could have. So there's even still trouble storing some of this data, let alone being able to do cool, fancy new processes on it. So we're in a place where we can be getting a lot of insight but it's a tough point of change where we need to be better at processing that data and being able to do it more rapidly. So as I mentioned, we've got those sensors, we've got all that data coming in. We also have a wealth of other data in manufacturing. So there's your power consumption, there's the information and data about the products that you're producing, things like whether there's defects, quality control processes. You've got data on your employees, and a MAT session on social distancing and IoT is going to be really important because you need to know where people are on the floor. That can help with your standard processes, but now being able to get operational and run your processes, but making sure everybody kind of stays out of each other's way is going to be key. You have your inventory, your orders systems, and you've got all that data on where your product, on suppliers and the upstream lineage of the things that get combined into your manufacturing process. So there is a huge wealth of data there. We have a more general AI in manufacturing webinar that goes over some of the use cases for some of these different types of data. But as I said, we're focusing on the sensors primarily today. And we look at the sensors through, I tend to look at it through the lens of the historians. So these are devices that sit with your machinery and consolidate the data into a single analyzable view. Like the GE historian, their latest versions can consolidate the information and put it into what's called a data lake, which is a big raw data storage capability that then machine learning software can then be processing and doing real-time detection processes and things. So this is the kind of data that we're going to be looking at. I'm not going into the specifics of different detailed types of historians that you can get. If you don't have any sort of data consolidation on in your environment, and that's something you're interested in, I can refer you to some people who are specialists in introducing historians and data capture methods and things into your environments. So we're looking at historians, and these are useful because they provide us with that real-time view as to what's happening across the entire system. And they're also your single source of truth for saying what did happen for things like reporting. So having that common data set means that you can get consistency and never have that worry about this says the temperature was this and this other thing says the temperature was that. It's important to have that trustworthy, high quality data longer term, because you're basing more and more decisions and possibly ceding more and more autonomy to systems that use that data. So quality is vital to make sure that you make the right decisions. So how do we get AI going with our historians? Okay. I like to think of the process that you're going to go through as the same sort of processes that you would put a human through. You don't take a new untrained human into your environment and enable them to make all sorts of decisions. You start off with the apprentice in low responsibility, high learning opportunity positions. They start building up simple rules about what's normal, what's a problem, and they usually start learning and cut their teeth on a few known systems. You don't ask an apprentice to watch out for problems on the entire floor. You ask them to look out for this piece of machinery for the day. And you let them learn, and you expect them to holler when something goes wrong. So they're not in a position of responsibility at all. Their position is to learn. You gatekeep you put guardrails around them so that they can't go too wrong. And you expect them to have a very high level, a nuanced level of understanding about what's happening. So step one inside the AI journey with the data from historians is going to be the apprentice level. The next level up is journeyman level. So here they're starting to understand. They have contextual rules, they have a breadth of experience, they've seen things go wrong, and they're starting to be able to be proactive and preempt problems before they begin, because they understand in more detail how systems work. And then the final level is the master, the person who has internalized the nuances of lots of the systems and is able to start doing things kind of almost from gut feel, where they can see from this complicated set of very subtle cues that there's going to be an issue. And this person is usually given significant responsibility. They are trusted to make decisions, and they might be asked for validation after the fact, but you're not going to quibble with them when they're saying, you need to shut that machine off right now. So this is the kind of the journey that I think most manufacturers should go on in terms of AI. You should be treating this technology like you would a human who is going to end up with responsibility inside your organization. So you're going to help them, first of all, do simple rules and alerting, where they're low responsibility, low trust in that you don't let them do things that they really shouldn't do. And you're going to start out with just a few systems. So at that point, it's very experimental. Then you add in more nuance, you give them more scope, you work on more systems, you give them more detail. And then the next level up, once you've had that sort of positive engagement at the journeyman level, is more control over the system so that they can start making decisions without necessarily have approval beforehand, with the aim being that they pick up subtleties that are otherwise going to be missed. So what does this look like in terms of specific AI technologies and concepts? So at the apprentice level, the key thing that you can be doing is time series anomaly detection. So that's the first type of process that I showed you, where it takes different series of data, so things from the sensors, works out what's normal, and when something deviates from the normal, it fires an alert. This they might end up a chatty Cathy. They might send a bit too many alerts, or they might not be very they might not be sophisticated enough to pay attention, and they might not send enough alerts. And this will be the point at which you start learning your internal appetite for whether your systems should be notifying people and working out what sort of processes need to be going on for the Apprentice AI solution to be interacting and helping your staff make decisions. In the Journeyman level, you continue doing that time series stuff. That is bread and butter. Everyone needs to be able to look for anomalies and problems and spikes in and cutouts in data and be able to go, hey, there's a problem here. But we can start going to that next level and saying, when these combinations of values occur, there is likely to be a problem. So that as we start seeing some of the, we can start putting in more sophisticated rules and monitoring systems to say, hey, we're seeing this evolving set of combination of values, and we know that when this happens, we're likely to get a problem. So we need to schedule a repair person to come in the next 4 hours. Otherwise, we think there's going to be a big fault and we're going to have a lot of downtime. So that should be working to start preempting and supporting scheduling of activities inside the organization. So you can see that has a lot more trust than simply notifying somebody to check something out. Then the final level is the master level. So the idea with this is usually this is where we start putting these systems kind of having decision-making capability based on a wide range of data. The goal using deep learning here is that we can use these systems to optimize the processes. So for instance, if it starts thinking that there might be a breakdown because the RPMs and things have increased and it's caused all the temperatures to go up and you're likely to get defects, it might have control to be able to say, decrease the number of RPMs and let's slow down the process, try and get things under control. So that has a lot of responsibility and a lot of trust, and you don't just do that overnight with anyone. Okay. So in terms of your journey to, or what you might be thinking about for getting AI inside your manufacturing processes, you might be thinking about what's next. So first of all, do think about this as a journey to train someone up. No person comes in being able to do everything, and no group of people are realistically going to trust that brand new person to come in and be as competent as somebody who's been there for a decade. So there is a process where you will grow your capability to process data, grow the test cases that you're using this on to prove that it's working, and to help gain trust inside the organization. And this helps your staff adjust processes over time so that they become more productive with the support of this solution, which means that they can start doing higher value things or providing overwatch on the process. And doing it, first of all, at that apprentice level means that your investment in this technology is also going to be lower because the processes are ultimately simpler and you do not need as much data, and you don't need to have consolidated it into a data lake or something. Most historian platforms should be able to perform some sort of time series anomaly detection, even if a very rudimentary option, and plugging in more sophisticated models is fairly achievable. Moving up in terms of capability means moving up in terms of investment as well. But like most things, the value of a well-trained person and a well-trained AI is that they do what you need when you need them to at a great level of capability. So we've also got some quick win AI projects. These are things like accessible meetings, being able to start doing some of the kind of the predictive maintenance pieces using desktop tools like Power BI from Microsoft, and being able to help like your marketing and your sales people do things by buying off-the-shelf AI kind of software modules into things like your ERP system. We have more detail about manufacturing and AI on our blog, and we have our past webinar on AI in manufacturing, where I look at some of the more broadly at the various use cases for AI. I delivered this talk in the past to the manufacturing sector at the Emerging Tech Fest, and have written up the competency model and how you go, how you train up your apprentice AI to a master AI, and you can go and read that online as well. So thank you all very much for attending today. Nightingale is founded to help businesses adopt AI. Fundamentally, that's not a technology problem. That's a people problem or people opportunity. In that, as we said, it's about making sure that the processes are right, that the people understand and can trust the solutions, that you know why you're doing it, where you want to go with it. So we focus on the strategy, the education, and the implementation of the technology with you. And we also we have right now and always going forward, I regularly have meetings with people to just discuss their situation and kind of flag up potential areas of investigation. So if the historian and AI topic was of interest to you, you can send me an email, steph@nightingalehq.ai, and we can discuss things further. I do also recommend, if you want to get more technical on this, next week, of course, I'm talking techie on this, and I think that Matt's talk on how IoT can help do real-time social distancing support for your staff is going to be really important for people to get to help businesses get back on their feet going forward. And trust is a key thing and part of this journey that I've discussed in terms of why you don't just try and go to the all singing, all dancing AI solution. So understanding what trust means in different scopes is important. Thinking about how do you get staff to be making data-driven decisions and predictive capabilities is Ashwini's talk, how to become a data science company. And then Ian's talk on privacy is going to be really important if you're thinking about things like IoT and enforcing social distancing, things like shop floor, real-time like health and safety analytics and things like that, and being able to understand some of the things that you want to think about when communicating with your staff about whether these solutions help them and how their data is going to be handled and all sorts of things like that. So all of these sessions help prepare you for adding technology that changes people's experience of your company on the inside and the outside. You can register at nightingalehq.eventbrite.com, and really thank you very much for listening, and I hope you got something out of it today. Thank you all very much.